Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review everything covered in week 1. So we just had an introduction to logs. Turns out logs are the inverse of exponentiation. Taking a log undoes raising a power. So these two equations here are equivalent. They say exactly the same thing. This is in logarithmic form, this exponential form. So log AB equals C is saying that this base needs to be raised to this power to get this number here. So log 2 of 32 is saying, to what power do I raise 2 to get 32? The answer to that is 5, because 2 to the power of 5 equals 32. Now, if I have log 2 of 20, that's not so easy to do in your head. I doubt anyone could. It's an irrational number. This was easy because 32 is a power of 2. But 20 is not a power of 2, so we need our calculator. Now, most scientific calculators only allow you to input base 10, so we can use the change of base formula here. So log base 2 of 20, if I don't want to work in log 2, I can work in log base 10. So to change the base, we put log and the base we want to work in on top and bottom. So the power, the number 20 goes on top and the base goes on the bottom. So I could put it in my calculator like this. So note, when you just write log by itself with no base, it's implied that it's base 10. So in your calculator, you can just put log 20 over log 2 and you get about 4.32. Why is that the answer? 2 to the power of about 4.32 equals 20. So what about this one here? Well, we couldn't put this on our calculator, but with some ingenuity, we won't need our calculator. What I want to do is write this as a power of A. So what is 1 on root A as a power of A? Well, square root of A is to the power of a half, and because it's on the bottom of a fraction, it's minus a half. So when you see an expression like this, it's actually really easy to work out. So this expression is saying, what do I raise A to get A to the power of negative a half? And of course, that is negative a half. All right, let's now look at some log laws. So there are 3 log laws you need to know. When you add logs of the same base, you multiply their powers. When you subtract logs of the same base, you divide their powers. And when you have a second power, so base power, second power, you can move that second power to the front. These are just analogous to index laws. All right, so let's look at some examples. So what would we do with this one here? We'll write it as a single log. So what we do is we keep the same base and we multiply the powers. 12 times 4 is 48, and then we're done. So what about this one here? Well, here we're subtracting logs, so we're going to divide the powers. We're going to keep the same base. Now, what is y squared divided by square root of y? Well, square root of y is y to the power of a half. When you're dividing bases, you subtract the powers. 2 minus a half is 3 over 2. And so the third log law actually tells us that we can write this by moving the power to the front and just writing it like this. So how would I simplify this expression here? Well, because I have a second power, I can move that to the front of the first one. So I get 2 log AB minus log AB. So here, I can't actually use the second law to combine these into a single log because of this 2 out the front. But people often forget these are just numbers. So 2 of something minus 1 of something just leaves you with 1 of something. This will just be log A of B, and we're done. So the point of all this, of logs and log laws, is to allow us to solve equations. So let's now look at solving exponential and logarithmic equations. So exponential equations are where the unknown is part of the exponent, and logarithmic equations involve logs. So let's do this one here. So what we're going to do is undo everything done to x in the opposite order to BIDMAS. So BIDMAS goes brackets and then the I index, which means raising to a power. Raising to a power gets done before multiplication and addition. So if I want to solve this equation, my first thing I need to do is subtract 4 from both sides. So now I'm going to divide each side by 3. So in order to figure out what power I need to raise 5 to get 12, I need to use logs. So on my calculator, I can put log 5 of 12. If you don't have a calculator that allows you to input the base, just go log 12 divide log 5, and you get about 1.54. So what does this actually mean? Well, this means that 12 is 5 to the power of 1.54. So now we simply have x minus 2 equals 1.54. Add 2 to both sides, you get x is 3.54 to 2 decimal places, and then we're done. So when we're solving logarithmic equations, sometimes we need to use our log laws. So we're going to use our log laws to combine these two logs into one. So what we do is we keep the same base and we divide the powers. This will be 3x over x minus 16. So to make this equation easy to solve, we actually need to make the 3 a log as well. So we want to write this as log base 3 of something. So what goes in here is 3 to the power of 3, which is 27. Log 3 of 27 is equal to 3 because 3 to the power of 3 is 27. So now that we've got logs with the same base on both sides, we can cross them out. We get 3x over x minus 16 is equal to 27. This is just a linear equation we've solved heaps of times. So 27 times x and 27 times minus 16. So then when we have the pronumeral in both sides of a linear equation, subtract the 1 with the lowest coefficient, and then you know how to solve this from here. We're just going to add 432 to both sides, divide each side by 24, we get x equals 18, and we're done. All right, let's look at this equation here. This is a logarithmic equation, but it's actually a quadratic. So firstly, what we're going to do is we're going to use our log laws to write this second term in an easier way. So log of x cubed, I can move the power to the front and make that 3 ln x. So it's a quadratic because we have something squared. Ln x is being squared. Note I can't use any log law to simplify this. So I'm going to let y be ln x. So I've got y squared minus 3 times y minus 4 equals 0. You can use polynomial solver on your calculator to solve this quadratic, or you can factorize. So if I'm factorizing, I'm going to get y minus 4, y plus 1 equals 0. And of course, the null factor law is I get y equals 4 or y equals minus 1. But I'm not done there. See, I needed to find what x is, not what y is. So if I let y be ln x, I have either ln x equals 4 or ln x log base e equals minus 1. So, how would I solve for x here? Well, this ln is just log base e. So, I would have x equals e to the power of 4, or I would have x equals e to the minus 1, which is 1 on e, and they are my two solutions. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.